As long as
yeah. Okay, so I took this one positive. I want to take this one, would be the same direction as this one?
Yeah.
Okay, so if this is positive, I'm going to take this one positive. So this force multiplied at the distance would be a moment. Yes? So I took this one positive, then go shear force times a distance, going to be a positive as well.
Delta x and distance, yeah.
Yeah, delta x is distance. Then you come across, start from beginning, and then you come to here. Is that another force is lurking here? This one, Wx, can you see that? W delta x is a force. I don't know, is a positive or negative should I put it here? Would it be going the same direction of this one?
Yes. Yeah.
So I think it's positive as well. Positive times a delta x divided by 2. You happy with that? Okay, there's another moment here as well, which is we had it already, I put it in there. If I'm gonna balance it, gonna be another moment there, minus a m, which is goes in the clockwise direction to get negative this time, equal by naught. Let's simplify this mess. In order to simplify the mass, would be m plus delta m plus s delta x plus w delta x squared divided by 2. Are you with me? Minus m equal by naught. Yes? So if I simplify, what's going to happen in the simplification? These m and these m, they're going to cancel each other. And then you're left over with the delta m plus s delta x plus w delta x squared divided by 2 equal by naught. What does it mean? Delta m stand for extra moment, little bit increasing the moment. Look at the beauty of that. We'll start from here. Okay, ladies, gentlemen, if I call it delta m this side and throw everything other side, can I do that? I can say minus s delta x minus w delta x, is it a square, yes? Divided by 2. And this is a square. And from here I can do the factorization, which is I can say delta x factorize that minus s minus w delta x squared divided by 2. Yes or no? And this goes underneath of that, would be a delta m over delta x is equal minus s minus half of the w delta x squared. Sorry, that would be 1x. Yes, that would be factorizing that. Are you okay with that? Now, creating an equation here. Watch me here. I'll create something like this eventually. Change delta m over delta x is equal by minus a shear force minus of the half w delta x. Do you remember the philosophy of the differentiation? Yes, differentiation, it means you cut into the pieces. Am I right? How small you can go?
Definitely. Infinitely small.
Infinitely small. And the smallest things, what would it be? Which is we can never gonna reach that.
Infinite.
Now infinite, what do you mean by infinite? Infinite, it means so massive. The smallest, if you have a birthday cake, you can cut it into many pieces, yes? The smallest piece, it can be very small, yes? But if there is no piece, what would it be?
Zero.
Zero. So, must be a piece, but you can approach the zero, but you're never gonna be a zero. Am I right? So, you have to tell me you're approaching to the zero. Small piece. Infinitely small, it means you're approaching to the zero, but you're never gonna become a zero. So that's behind that. When we have a delta m over delta, it basically is similar as a differentiation. So basically we can say change of the m with respect to the change in the x is equal by limit of. The limit of the is basically minus the s minus half of the w delta x. So when as delta x approach the zero. So if the delta x becomes 0, 0, 0, small, what's going to happen to this weight? Are you with me? Just imagine this was for this length. If this length becomes 0, 0, small,
Weight gets smaller.
the weight, everything gonna go small as well. So almost this is gonna approach 0 as well. Can I say this expression gonna approach 0? So eventually you left over, you can say this is a limit of that. So you can say differentiation of the bending moment with respect to the x is always equal by minus a shear force. Do you remember earlier I asked you the way you can check the bending moment with the shear force? Yes? Bending moment equation, if you wanted to find is it correct, what you're going to do, differentiate the bending moment with respect to the distance, it will give you the equation of the shear force with the negative sign. As long as you take a shear, one side positive, one side negative, yes? Sometimes you take a shear downward instead of you choosing upward. I saw some people when they do solving the problem, they take this one upward, they take the other one downward. So this one, d of the m, with the differentiation with respect to the x, it would be equal by s rather than minus s. Okay? In general, when you do the differentiation of the bending moment equation, it would give you the equation of the shear force. It means you are in the right path. Happy? Right. Right. That's it. What does it look like, this one to you? What's this one?
Different.
First order differential equations. This is a differential equation. Sometimes if you want to come back to something, solving the differential equation, what would you do? When we solving differential equation, we do the integration basically, am I right? And all integration can have a limit as well.